Arc length and sector area. This is a geometry topic. Hopefully you remember a little bit about this. Nice refresher here. Not sure if you used radians, so I'm not sure if you approached the topic from that angle. Pun intended. So let's talk about how we figure out our arc length when we're using a radian measure. So let me see if I can break this down so you understand why the formula is so simple with radians. All right, so if we have an angle, it's in radian measures of a circle with a radius r, then the length s of the intercepted arc is given by s equals r theta. So then there's the geometry formula. Let me explain that a little bit more in depth here. Okay, so this theta here is telling us how far the length around the circle, the distance around the circle in radians we're looking at for our arc. So in other words, that's saying how many radii have we gone around the circle? How many radii? And since each circle, sorry, let me back up a second. So if the angle tells us how many radii we've gone around, and the radius is the actual length of the radius, we have the length of the radius times how many radii, and so then we get the total length of that particular arc. When we look at it in the geometry formula down here, we kind of have a proportion going on here. We figure out how much of the circle we're looking at, how much of the 360, and we multiply that by the total circumference to figure out the proportion. So hopefully an example will help tie together what we just talked about there. We have a central angle. All right, diameter is 30. But I don't want diameter in my formula here. I want radius. So let me go ahead and change that. Radius is 15 meters. The angle is pi over 3. Find the length of the arc. So S equals 15 times pi over 3. 3 and the 15 cancel out, so the arc length is equal to 5 pi. My question was asked in radians, so I will give my answer in terms of pi. You try this one on your own. This one's in degrees, so you can either change it back to radians or use what I will call the geometry formula, which is already in degrees. In geometry, again, we have this proportional relationship. How much of the circle are we looking at? What proportion of degrees? And then we multiply that proportion by the total area to get just the part of the area that we're looking for. So if we want to use radians, we need to convert the degrees to a radian formula. So we get an area of a sector where, all right, so the theta over 360, well, 360 is 2 pi, so let's change, let me write that down here. So we really have theta over 2 pi times pi r squared. Oh, but lucky us, we have some things canceling out here. So the 2 in the denominator can be pulled out and just written as 1/2 out as a coefficient times theta times r squared. The pi's just take care of themselves there. All right, so a sector area example, central angle. So we have diameter again. Where, let's see, D equals 20, but I don't want D, I want R. And theta is pi over 4. So our sector area, which I'll just call SA for right now, is 1/2 r squared theta. So that's going to be 1/2 times 10 squared times pi over 4, which 10 squared is 100. And 1/2 of that is 50. So continuing up here, we have 50 times pi over 4. That's 50 pi over 4, which is the same as 25 pi over 2. I'm leaving it in terms of pi because my question was in terms of pi. I could make a good argument for converting it into a decimal approximation since it is a word problem, but I'm going to leave it in terms of pi unless it says round. All right, this one's on you. And that's going to be it for this one. Let me know if you have any questions.